So anyway, so we had a brand new project, Project Zero, and we created this project using the wizard. And there are a couple of things here we're going to point out right away. Okay, first, what is this weird thing with the slash stars? Comments. That's a comment at the beginning. Specifically, unlike this comment here, because this is also a comment, you'll notice the comments are gray in color. Okay, that's part of our syntax highlighting. Again, another gift from the IDE that clues you into what that is. This type of comment with the 2 slashes is a single line comment. Anything you type after will be considered code like thus. So if I go ahead and hit return and start typing, it's assuming that there's no more comment to come. The slash star slash is a multi-line comment. Everything between the slash star and the star slash is commented out. It's Java convention to put stars here, but they're not necessary. That's not a part of it's convention more than anything else. Deleting these does nothing to the comment. It just, makes the comment. However, when you do the slash star, what's going to end up happening is it will automatically do, when you hit return, it'll automatically put the ending one there. And so now that anything you type is multi-line and commented out. Okay. There are some templates in there. We saw the code templates. There are some templates in there that will actually put the stars in along the side. At this point, I don't have that. I must not have that enabled, so it's not going to actually put the stars in. All right. We'll come back to project in a second. So inside the properties too, there are settings for who you want as an author. It'll take the name of the user on the account. So I have the instructor account, so it's the instructor author. Okay. Obviously, if you want to change it, just change it. This @ symbol will actually output when you do something called a Java doc. We'll talk about Java docs in a moment. This is my class, public class, and my class name, Project Zero. Okay. Java deals with classes. This is an object. It has a class. When I compile it, it'll have a .class file, which is a compiled class file. And any methods on it that I want to use, because it's public, I would reference it with Project Zero. Classes in Java's organized, right? So classes are the things you use to do work, all right? A class is modeled after more or less an object or an entity. An entity will have properties otherwise known as variables, okay? That is a property of this class. Every time, you guys know what instantiate means, right? And I'll repeat it just for my own edification. Classes are like blueprints. Even when I compile this class doesn't truly exist. It's a blueprint. What you do is you create a new one of them. When you create a new one of them, you instantiate it, and you have something that'll actually be able to interact with other types of software. These properties are what an instantiated version of this is going to have. Right now, it'll have a private int called foo. So in organization, we have a class here. Now classes are organized in a hierarchy, and the base hierarchy is in a project, or a package, I'm sorry, a package. So what these package names really are going to be how you're going to organize the class. we'll create a new one of these in a moment. All right. So anyway, we got this project. We'll get to the main in a moment. Okay, so does everybody have NetBeans? Just finished it? Are you okay? All right, create a new project. Call it Project 0. We'll talk about main in a minute because we're going to do another one of these. Then we'll start going through.
This is just Java application.
Yep, Java application. Just in the application name, put
Project 0, you said.
mm-hmm. Sorry, I'm just finding. I gotta find the. I'm not usually in NetBeans, and it pisses me off. Here we go. Okay, so now that we have our project, we're ready to submit it as an assignment. So we're going to click on Export Project to Zip. Okay. When we do that, obviously it's going to build the zip here, but you can export it to wherever. When you click on Other Directory, you can just browse or browse to build the zip. Like if I want to build it in Documents, Workspace, sure, no, or not. No. NetBeans projects open. All right. So if I want to export it, I'm going to export it here to this directory. Don't mess with the build zip, I guess. You click Export, and then that project is going to be right here. Okay? And that's what you would submit, is the zip file. Because then what I can do is to look at your code, I can import that zip file into NetBeans, and I'm running your code. Okay? Ooh. Jeez, that's loud. All right. So let's talk about the main method here. Okay. We're going to be actually writing a number of classes that have a main method. And the book is going to have tons of examples of you actually utilizing the main method. I'm going to want you to absolutely ignore all of them. Okay? So in normal programming, you don't use a main method to drive your program. You might use it to start it, to initialize it. You might use it to go get other classes, assemble them, and then have those classes run stuff. But you never run your whole program from main. Okay? The reason is there's a couple, main is a pretty special program. That's where a start of a program will be for a desktop application, essentially. So you'll have this main method that you'll call and it'll actually run and start the program. All right? The problem is that the main method is pretty restrictive. What do I mean by that? Well, there's this keyword called static. And what that means is that you can call main from outside of the Project 0 class. If I do a class called Run Project 0, so let's do another class. We're going to click on Project 0, New Java Class. Okay? You can right-click on Project 0 or do File, New Class. Okay? If we do a new class, let's call this class run project 0. Okay. We're going to keep it back in this project 0 package for the moment.
Where did you initially go?
Hang on, let me cancel. So I right-clicked on project 0 here, on the source package here, and I chose new and Java class. And we're going to say run project 0. Of course, if I could spell, that would be even better. I can't spell, I'm a developer. Worse yet, my first degree is in English, and I was a poet, so I doubly can't spell. Or let's put it this way, I hate spelling, so it's artistic license. So, so we're going to have run project 0. Now, run project 0 is not going to have a main method because you can only have one main method in an application. All right. And why did I name it run project 0? Let's do this. So one of the things we're going to do is we're going to show you something. So I really named that stupid. I'm not going to run project 0 from run project 0. Project 0, this is going to be the class that project 0 is going to run, right? So what should I name this? I don't know. Any suggestions?
Zero method? Zero method or something?
Zero method?
Yeah.
Project 0 methods. Let's do that. So what I'm going to do is I'm going to double click on this run project 0, and because it's a bad name, I'm going to right click on it and I'm going to go refactor, okay? And by the way, when you rename methods, when you rename properties, when you rename classes, you always want to do it in the IDE using the refactor, okay? Because what it will do is it will search through your code, and everywhere that's being used, it will change the name there. So you don't have to hunt for it. So I say refactor rename, and I'm going to rename it to, what did I say, project 0 methods, Shaq? Is that what we? Yeah. Okay, sure, that's better. Okay, and notice I only changed here because we're, well, project 0 methods. All right. So let's see, project 0 methods. Okay, so when we're designing a class, we have properties, so we have things that the class has. So I don't know, let's, every class when we set it up, with some exceptions, as we decide what properties it's going to have, those properties should really remain private to the class. We shouldn't let other classes change those properties. What we're going to do is we're going to use the private keyword. Okay? There are 3 keywords in this context. There's private, which means only my class can make changes to it. There's protected, things in my package can make changes to it or can use it. And public, which means anybody can. Okay? Any class can affect it. So in this case, we're going to show this in a moment. So we're going to do a public int foobar equals 1. Foobar is the essence of programming.
Why does string have to be capitalized?
Ah, good question. Hang on one second. Let me just finish typing here. String has to be capitalized because string. So these are primitives. Okay. So int, the lowercase I int, the lowercase b Boolean. these are primitives. These are not actually classes, okay? Primitives are special in Java. For every primitive, there is a class version of it, which allows you to do things like pass it into methods and have it actually retain the values when they come back out. So, and they act like classes. Say that again?
Say that one more time.
Oh, so when we're passing around primitives in methods, okay, the primitive's going to get copied. However, when you pass a class into a method, the actual class you're passing in is going to be retained, and any changes you make on that class will usually survive, probably always survive, the actual method changing. Okay. Whereas string is an actual class. All classes in Java, string, project methods, have an initial cap. Okay? It's all camel case, but the initial cap signifies it's a class. You don't have to do that. I can call this foobar. I can call this barfoo, and I can call this isChanged. The problem with this is because the capital for a class is such an ingrained convention in Java, doing this will only confuse every other developer you would ever work with. Okay? Because they will expect this to be a class name, not a property name.
Oh, all right, so I get why the string is a class. Why is the int not?
So the int is, these are Java primitives. Okay, so these are primitive data types. For every primitive data type, the int is like immutable. You can't act upon it as you act upon a class. It just is a 1 in this case, right? You can set it. It's a property of this class. It's an integer, okay? But there are some things you can't do with it. It's not, you can't interact with it the same way you could with a class. If you wanted to do that, you would have an instance of the integer class.
Okay, so there's an actual integer class, but you have to type out the whole. Okay.
It's just, and there's an actual Boolean class.
Okay, I got you.
Okay.
Okay, that makes sense. I didn't
Okay.
realize that there was one of those too. That's why I couldn't figure out why you.
And the reason I'm showing you both is because there are reasons you would want a primitive, okay? A class is a larger object. There's a lot of setup, a lot of takedown, a lot of stuff Java has to manage in the background. Java has something called garbage collection. We'll talk about that at a later time, but things hang around in memory until Java decides it needs to get rid of it. Primitives take up a lot smaller space. So we're not going to really be concerned about space. So if you want to use all classes because you think you're cool and it's a cool thing to do, by all means. If you see int, feel free to substitute an integer class for it. I will not dock you points for that, okay? If you want to be smart about it, or not smart about it, but if you want to be Mr. Fancy Pants and use a thing, I'm not going to dock you because we're not concerned about size of programs or space of data.
We could use a lowercase. We could use the string primitive as well, correct?
There is no string primitive. There is no string primitive.
Yeah, that's what I was wondering. So the one has it, and the other one.
The only thing that is comparable to a string primitive would be something like an array.
A char array.
Oh, it's going to actually want me to do the array.
Or instead of,
Actually,
isn't it just the one quote?
There.
Oh.
The reason I can do this is because Java knows this is a string. I've encased it in double quotes. And because string is a class, string has a bunch of methods on it. One of them happens to be 2-character array. So what Java does is it's smart enough to know this is a string. It converts that to a string object automatically. Then when I hit the dot, did you notice that? That's part of the auto-completion. So because this is a string, when I hit the dot, I get a list of possible things I can do with that string object. Note the one at the top of the list. It knows I'm looking for a character array. So the first one it presents me is 2 character array. Okay? That's what I mean by code completion and letting your IDE do the work for you. Okay? And note here look, it tells you what it's going to return. These are your return values over here. If you see void, it doesn't return anything. But these are the return values of what these methods return. Have I lost anybody right now? Okay. All right. So 2 character array would be something, and I could have done, you know, at this point too, I could have done bar foo 2 character array. I've declared bar foo up here, so I can immediately use it in the next line. But this is as close as you come to a string primitive. That's the closest you come, is a character array. Because you can convert character arrays to and from strings pretty easily. It's just not really done all that often. It's not. When you got a good string, you just use it. You just use the string class. There are instances where you would use a character array, but they're not real common. And if we cross one, we'll talk about that when it happens. Excuse me. Okay, so you got Project Zero methods. This is great. All right, so here we got public, protected, and private. Okay, so here I am in my main class. And I've got my brand new Project Zero method. So I'm going to say, hey, Project Zero methods, PJM equals new Project Zero methods. Okay. This instantiates a new Project Zero methods. Now, how did I do that? Well, number one, with the keyword new, so I'm instantiating a new version or a new instance of the Project Zero methods, but also every Java class has an automatic, what they call a constructor, okay? Every class has a method with the class name in it called a constructor, and what that does is it builds a brand new version of that class. Constructor would look like this. And actually, you can, there should be one, insert code, constructor. You see that? I wrote it. Do that again. If you right click inside of your class, whoop, let's cancel that one. If you right click inside it, stop. If you right click inside of your class, you've got a little pop-up that says insert code. There's also Control I. And this little list will come up. It says generate. What do you want to generate? You want to generate a logger, a getter, a setter. We'll deal with getters and setters in a minute. Constructor is one where it's going to build it, and this is a no argument constructor. Okay? There's no arguments passed to it. It's got the same name as the class. Always has the keyword public. There are instances where you'd put a protected constructor or even a private constructor, but this is not one of them. Private constructors are pretty rare. There are special use cases for those. It's not something we touch on here. But anyway, we're going to be using public constructors for the most part, if not exclusively. So this is a no argument constructor, but what can a constructor do? Well, constructor could do something like this. So a constructor can set its own properties. In this case, I didn't set foobar equal to 1. Now with the constructor, I'm setting it equal to 6. At this point, I've created this new constructor, so we no longer get the default. It's going to use the one I created. The default is only there when you don't have one or you don't code one. I could also have taken this constructor and I could have created one. Let me copy the whole deal. I could have created one that says that took an integer as input. So this is my parameter on this constructor. It could take this input and I could go ahead and set my foobar to this. Now it's the use of this keyword. This keyword basically says, hey, I want my instance, right, and my foobar of the instance of this class to actually be set. That's what this keyword does. I like using it. You do not have to, but if you don't use it, you can't do this construction, which actually a lot of developers do. They pass in what really they want to set. If I've got 7 strings on here and I'm setting them all through constructors, how do I know which string goes where? And I don't want to do string 1, string 2, string 3. That's insane, right? You're going to mess up where they go. So usually you would use the actual name in here, and at that point you actually have to use this keyword, because then you're telling this foobar and not that one. And if I take away the keyword, you're going to see, is it going to give me a warning or an actual error? It's going to give me a warning. Notice it underlined it in yellow, and it's giving me a warning saying, hey, these are ambiguous. What does it say? Assignment to itself. Okay. Now if I change this, if I change the name on this, then that goes away, because now it knows which foobar I'm dealing with. Okay. But if you do this type of construction where you name it the same coming in, so you know what you're setting, then you want to use this keyword so you don't know exactly where things are going. Okay, so back to our project 0. So now we've got a new project methods class. Okay. Now here's the public-private keywords in action. So here I am inside of this class. I'm not in the project methods class, but hey, I can go ahead and access foobar and bar foo right from the command line. I don't have to use methods. I don't have to have any of that control. I can just go ahead and set those properties. This is a bad idea. The reason it's bad is you lose control over how those properties are represented. Let's say I had to verify that a number was greater than 0 before you actually give it to me. Well, if I do this, then I have to check if it's greater. I have to put an if check around this. I have to put some choice code around this to make sure that that integer you're giving me is greater than 0. One more thing. Notice that barfoo has this little bitty key on here. We're going to do one more thing. Let's go into, click on, yeah, that's fine. Click on source packages, do new Java package. And our new package is going to be project 0-1. Nope, not dash. Sorry, it won't do that. 0_1. So our package name is project 0_1. Okay, click finish. And inside of that package, you do a new class. Now we could have done a new class and then just put it into a new package there. So you have that option. It will create the packages, and I'll show you how that looks in a minute. So let's just leave it as new class. And no, okay. So we're gonna I'm just putting a method in here. Doesn't mean anything. Public void, show example. Void is the return type. Go over that in a moment. So what I'm going to do is I'm going to come over back here. I'm going to copy this line here with the project methods. I'm going to copy that and I'm going to paste it into the new class here. When I paste it in, notice I get this line here. Import project 0 project methods. When you start using classes that are not in your package, you need to import them to get them to be used. We don't need it for strings. String's part of the language itself. It's kind of like included. It's a freebie. Same thing with integer and Boolean, that sort of thing. But once we start using, you'll see what ends up happening with these import statements as we start using more and more classes. Anyway, so we've got this import. Now if we go PJM, right? Now we're going to try and change, whoop, where did my barfoo go? Remember what I said, protected is within a package, right? Now we're in a different package. Now we no longer have access to barfoo. This is what I mean by protected is within a package. Okay? Okay, I'm going to remove that. So let's go back, and we're going to go back to our project 0 methods. And so we can make this correct, in my eyes anyway. We're going to change on all 3 of these properties, we're going to make them all private. Okay?
Java,
pardon me?
in Java, are they automatically private if I was just to type in int?
No, they're automatically public.
They're automatically public.
Automatically public. And you never want to. You always want to specify your what is it called? It's not a scope. You always want to specify that modifier, okay? Because you want to be sure that you know how visible it is. For methods and for properties, if you don't specify that, it defaults to public. Okay, but the thing is, you're not really going to know that, and it's not really convention. It's convention to actually just specify it, to spell it out. So when we have these private ones,
under your project 0,
yep.
your very first one, why is it's showing an unknown now? Yours isn't.
See that? New class. Oh, okay. It didn't import. So, project 0 oh, I'm sorry. That should have. Let me look on. I'll get you the keyboard command for that. Oh, so Shift Control I think Control Shift I. Type Control Shift I while you're in that class.
In the first one.
Yep, in that new class, and it should import. It should fix that import. It should go ahead and import that.
It works, yeah.
Control Shift I. Every IDE is different. I don't have project zero methods. Oh yeah.
Okay, so
Why is it? I don't know. Why is it still? Oh, you don't know what. So number one, you need a semicolon on the end.
Yeah, I tried both, that's what I was, that's what.
Oh. You didn't have a zero argument constructor, and when you write a constructor and you write a zero argument constructor, if you don't see this has no arguments, once you write one constructor, like a constructor with an argument, if you want a zero argument constructor, you have to write it as well.
So I have to write two separate constructors.
If you want, so if you do if you want a zero argument constructor, you don't even put a constructor in. You just let the default happen. Because the default is it will provide one for you automatically. The language will. If you want multiple constructors, but you also want the zero argument constructor, you have to write them all.
Really?
Yes. Because once you've written one constructor, the default goes away. It assumes that you've chosen the constructors you want. It assumes you know what you're doing. Okay?
Otherwise I have to go back in the new class that I built and I have to put in.
So I put in a zero argument constructor initially. That's why mine worked right away. So here, if you go back to my methods, you'll notice this was my first constructor. Okay? I wrote the zero argument constructor. I just showed that you can also write one that takes a parameter. Okay? But notice I left this one in because I already used it.
Changed it instead of leaving it in there. Sure.
And this is the reason you would write your own zero argument constructors. If you need to do some housekeeping in the class before you actually instantiate it, whether it's set up variables. Let's say this class is a die roll, right? What is a die roll? Do you pick the number? No, it's random, right? Well, maybe I want to generate that randomly as I'm creating the class. Well, I might write a zero argument constructor that says, calculate die roll, right? I might have some complex function that pings, NASA satellites and takes that value and calculates a random value from it. Well, great, but I don't need anything coming in, so I would write a zero argument constructor, does all that work, and then assigns it to whatever my die roll is, okay? That's one instance of where you would want to do something like that. Random is one thing, but there are other ways to do it. Especially if you had default values that you wanted to set up in the constructor versus setting them up actually as property equals something. That's another reason. So now these are all private and we can't change them anywhere because they're private. They can only be changed in this class. So how can we change them? Well, what we do is we generate getters and setters. Getters and setters is a shorthand for methods that will change these values. So setters mutate, meaning they change them, and getters will access them. They're accessors. So if you do insert code and you choose getter and setter, now notice we've got a little lock on here, meaning it's private. You can select all of those and select generate. And it will go ahead and generate all these methods for you. Again, it's a really easy way of building classes. You write all your properties that you intend, you right-click, you generate all your getters and setters. Especially for classes that are just meant to hold data. Remember we were talking about, in SQL, we were talking about employees? Well, let's say you query an employee database. You get all these employees back into your program that you wrote because you're going to show them to somebody in a program. So you get all these employees back. What are you going to do with them? That's kind of tough. Because guess what? SQL is great for finding and accessing data and doing all that stuff. It is crap on layout. It doesn't know what it's doing. It's got rows and columns. And I don't know. How are you going to display that? Well, if you do an employee class, then you can copy those values into the employee class. Well, we will be doing a little bit of that. We'll touch that later in the semester. Okay. So now we have a class. Now we have getters and setters. Now at this point, 5 more minutes and we'll have a break, okay? At this point, now that we have our project methods, we can do PJM, and now we've got get bar foo. We got, these are the classes we wrote, the ones in bold, okay? Got set bar foo. We'll do that in a moment. So if I want to set bar foo to something, okay, now I can do that. Now remember I said, well, what if we have to check if a number is greater than 0? And if we had to do that every time we set that value, that's annoying. Well, now we can go into our set foo bar, and we can say now we can go in here and we can say, oh, if this parameter coming in is greater than 0, then we'll set it. Now I've got an automatic check every time I set the value to do that. And that's why we don't use public properties. We use private properties. We use methods to access them because it gives us greater control. Okay. So we've gone over public, private, protected. We've gone over the classes themselves. We've touched on this main method. Oh, the reason we don't use main all the time is because if we wanted to say, if I want to say set this, I can set this from within this class, right? See that foo? I could say, well, I want to do foo equals 2. I'm getting an error. Why am I getting an error? Man, that's confusing. I'm private. I'm in my own class. I can set foo anytime, any damn little time I want. Excuse my French. Not that you haven't heard the words before. But anyway, anytime I want, I can set foo. I'm private. I'm in my own class. I don't care if it's private. I can set it because I'm in my class. Well, the problem is this is static. Since static things, because we can make anything static. Since static things are accessible outside of our class, okay? Mind you, over here, when I was in project, so this main will be accessed as part of a running of the application, and we'll see that in a minute. But because of that, anything that goes inside of that static method has to also be static. So to make sure that foo, I can actually use foo in this instance, I would have to set it static. Nobody does this in the industry without a really good reason. Static things can be accessed from anywhere, okay? Well, private static's not, but public statics can be accessed from anywhere. And you'll see public statics a lot, okay? They're used a lot in how classes are defined. So if I said, let's do here, I got foobar, so get foobar.
Thank you.
So some of these classes, right, are I've declared this variable law here, and I've set it to this integer. Okay, so law has some classes on it I can access. Okay, but also the actual integer class, has a number of stuff. These are all statics, by the way. Okay, as part of the integer class. We can see what our min value and max value of a particular int is, of the integer class is, size, type. We can take, where's the famous one down here? Probably the most used one in is parse int. Okay, so if I have a string coming in and I want to make it an integer, okay, I use parse int and it will actually return an integer, unless it's not an integer. Notice down here, and this is again where tooltips and everything comes in handy. If it's not an integer, what is it going to do? It's going to throw a number format exception. We'll get to exceptions later in this semester.
Is there a try-parse in Java? Like a try-parse in Java?
Try-parse?
So we'll try to parse it if it doesn't.
Right. Well, it's going to, so parse int here is going to actually parse it. And if it can't parse it, like you entered in A instead of a number, it's going to throw a number format exception. In this case, we would catch the exception. We would say, hey, dummy, you entered in something not good. Try it again, or something to that effect. We'll go over that later. Just know that Java has something that's called exception handling. When things go wrong, you can either choose to do something about it, you can catch them and do something, or you can just let them be, and it will bubble up to the screen. It's usually best if you know it's going to happen or potentially happen to do something about it. Why don't we take a 15-minute break? Am I going too fast? But by the way, before I let you guys go, am I going too fast? Are y'all confused? Yes? Okay.
It's been a summer,
Okay.
so.
Let it sit. Take 15 minutes. Go get some water. Go to the bathroom. Come back. I want questions. What do you want me to go over again? What do you want me to expand upon? What do you want me to dive deeper into?
Start from the top.
Start from the top. We can do that. I'm not opposed to doing that. I am here for you. I talk very fast. And I know I'm kind of jumping around a little bit, but really, you know, you need to type this stuff out and get practice with it. So what I'm going to do is I'm going to wipe this project out. We'll create a new project when you guys come back.
Cool.
We'll start from jump. Kinda. From jump. Air quotes. And is anybody bored out of their freaking mind? Please raise your hand. Are you bored out of your mind? Am I like going over stuff you're like, my 3-year-old can do this?
I want to hire your 3-year-old.
No?
Yeah, it would-
Okay. All right. Well, I'm not my 3-year-old. Your
Maybe I'm
3-year-old.
looking for new 3-year-olds. They just put out a big ad, I was hiring people.
Actually,
They wanna know you can do it, but yeah, they didn't care about degrees anymore.
Well, if you've done something, then yeah.
Well, look how many kids are growing up with it so much so now.
I think it's always been a meritocracy, you can do it.
It's one of the few industries. You can hack stuff or you can't hack stuff or, it's like the CIA, they don't care if you have a degree, if you can, or NSA.
But that's what the portfolio's going for.
Yeah.
If you're,
Look at, I hacked WikiLeaks, can I have a job?
That's why I spent my whole summer on was just trying to get my GitHub up. Decent.
What was what I was doing? Okay. And we are going to. Oh, here it is. Okay, guys. In Blackboard, I created an area called Class Resources. So any projects I have in class, at the end of the day, I'm going to zip them up and put them out there, so that if you want to download them and import them in just to see what I'm doing, there will be a number of projects as we go through that I'll be throwing up there, because I have some that are pre-done to show stuff. So I'll be putting them up there. Also, we can then, I can show you how to import. I'm going to redo exporting as well. And I had it wrong, that zip line does work. The line, we need to change that. So, actually, I'm going to get some water too. Be right back.
For the class structure. Okay.
All right, just before we get started. So I put out here, I'm starting to put class resources I got for week 1. Here's the Project Zero I just did. I put it out as a zip file. I want you all to download it. We're gonna practice importing it as well. There's also 4 links out here. We'll take a quick look at one of them. Java naming conventions is like the things I've been talking about. Class names begin with a capital letter. Package names have certain rules on how they're named, and we'll look at that more in depth in a minute. There's Java tutorials. So Oracle's got a good section on walking you through Java and what it's about. It is probably updated for 10, but should still be applicable pretty much for all of it. There's also the Java API documentation, and this is the link I'm going to actually click on. So Java has a lot of class files and a lot of content within the Java development kit. If you have any question as to what a class does, the methods on the class, the properties of a class, it is going to be here. So just to look at one of them, if we look at string, which should be here under ST, and it's alphabetical. So here's string, right? We see that string descends from Java Lang object. Now Java Lang object is the base object for every class, including ours, okay? So everything inherits from object. We'll talk about inheritance later, but just know that it inherits from object. We can subclass string, we can inherit from string, and have all the properties of a string. We can do that. It's allowed for any class in Java pretty much, any full class. We'll talk about what that means later. So Java extends object. It implements serializable, comparable, and character sequence. So Java has a notion of 2 types of classes. There is an actual class with things and methods, and there's something called an interface. So when we think of inheriting things, we're saying Java extends objects. So Java is an object, okay? It's an is-a relationship. I extended, I have an is-a relationship. These things are man, I'm losing my mind. Okay, they're interfaces, and we can implement them, which means that we also take on the nature of those particular classes as well, those particular interfaces. We're going to explain what that means later, but just know that there are these things called interfaces, and we can deal with them. But you will see this when you see implements. That means it's implementing an interface. When you see extends, that means it is inheriting from a different class. You'll note there's a whole bunch of text on what a string all is, but then you're going to see there is a lot of methods. One of the things that when we say it implements the comparable interface is we can compare 2 strings together. We can say this string compares to another string to determine, say, if it's greater than or less than, okay? And there's all these constructors, the fields are there, and the methods are below, okay? So if you ever wanted to know, well, what methods does this random class have, Java API is where you come, and you'll find out all about it. The extensions, you'll notice that they're not all from, they all start at object, but they cascade down. Some are 7 or 8 deep. It's very interesting. But so if you're looking and you're like, well, what, I see the methods on this class, but I want to look it up. That's where you go. And then there's also a NetBeans quick start, which will give you some quick start information off of NetBeans. All right. So let's go back to the project. We are going to, what I want you to do is right click it, click delete, and say also delete sources under instructor project 0. And click yes. Project's gone. Great. It's gone. But what if we wanted to import it? Well, if you downloaded the zip off of Blackboard, you can say File, Import Project. Now here, again, we notice that NetBeans is a competitor to Eclipse. You can actually import Eclipse projects. It's kind of neat. But in this case, we would import from a zip because we know it's a NetBeans project. If I browse for a zip file, like I put mine on my little instructor thing here, and then I click import. And my project's back with all the source files and everything else, including, come on. I guess I didn't save this. New class. Must not have saved everything. Yeah, well, I'll do it again. So we're going to delete whatever projects are out there. We're going to start from scratch. We're also going to name our, so what I want you to do is right click projects or just choose File, New Project. We're going to do another Java application. I'll do something a little more substantial this time. Come here, you. We'll do something a little more substantial this time. Hang on a moment. I figure out how we're gonna. So in our project name, we're gonna do order pizzas. Now what I want you to do, or this is, order pizzas is the project name. We do pizza orders, whatever you want to name it. I'm actually going to do that as the class name too. Oh, should have done next. Okay, order pizzas. If it came out like this, what I actually want you to do is I want you to right click on this package and we're going to refactor and rename this package. So one of the Java conventions is when we're doing package names. For companies who write their own Java code, their packages invariably start with com for company. Okay, you can also do org for organization, edu. These may be familiar to you. Okay, so since we're in MATC, we're going to do edu. Okay. And as we're part of MATC, we'll do that. Okay. Now at this point, the package really should be the class we're in. So it'd be ITDev 140. Okay? So every package you create should look like that. If you want at this point, you could add your last name to make it unique to you. It's up to you. But I do want to see that edu MATC ITDev 140 in your package names. When you've named it appropriately, wait for is everybody caught up yet? Okay. When you've named it appropriately, you click refactor. If you want to see what it'll look like, you click preview, but click refactor and it'll automatically rename it. So now it is in this package. Okay, so this is an Order Pizzas app. This is like an extended Hello World. and we're going to have a couple of different classes in here. Okay. So if we want to order a pizza, what types of things do we need for this application?
The size of the pizza?
Size of the pizza. Well, how about the fact that we have pizzas too, right? Yeah. Okay. So let's create a pizza class. Oop, wrong one. Let's create a pizza class. So new Java class, and we'll create a pizza class. You can leave everything else default. And as Shaq said, we want a private. Pizzas are usually in inches, right?
Where's new class under now? I've already seen that.
So you if you right click either your package or one of the other classes, choose new, or you can choose it from the file new should be source format. No, file new file. I would do it off of right clicking new and then Java class.
And just the edu.etc.
Yeah, you don't. Yeah, just right click that package name, and it'll drop it right in there. So let's we'll make it a little bit easier. So we'll say this is an integer. If I could spell, and we'll say size. Okay, we got private integer size. So we have a size. What else might a pizza have? Some of the things that you guys state we may not do because we want to keep this simple, but what else does a pizza have?
Crust.
Crust?
Thin or thick.
Sure.
Toppings.
We're just going to do this as string for now. Actually, if you were doing thin or thick, we would do it slightly different, but we're not there yet, so we'll keep it as a string. Y'all like rat poison on your pizza, right?
No.
Depends
No?
Depends on who I'm giving it to.
Well, and what I'll do here is I'll make it easy. So if we had say, if we wanted say a list of toppings, right? I'll just put that as a string array. We're actually not gonna populate most of this stuff. What are other things about a pizza?
Like the cost.
Hey, there you go. How much does it cost? So what? Okay, so we haven't touched on data. We've touched on data types a little bit. So we've said that there are classes for each of them, and there are primitives. So we're gonna dip into another primitive. We have integers, right? We have booleans. We have strings. We also have doubles and floats. Okay, because this is a price for a pizza, a cost. We're gonna want dollars and cents. So we're going to want it to be a double. And in this case, I'm just going to do a primitive double.
Does double also have a class too, or?
Capital D double. We'll be fancy. Capital D double cost.
I was just curious.
Oh yeah, it does. You're going to see, in any code you would ever see out on the net, you're going to see primitives used most often. Just because it's easier and you don't have to think about it. When you start getting into more complicated pieces, that's where you're going to see the actual classes used. Okay, I think that's enough. So right now, and we're not gonna create our own constructors. We're just gonna use a default. So we want to create getters and setters for all these. So let's just go ahead and right-click, insert code, and say getter and setter. That was right-click in the class, insert code, getter and setter. You'll notice, by the way, just as a, cancel this out, just as a note, here are your quick commands along here for each of these. So here, my insert code is Command I. Okay. So if I didn't want to right click, if I'm, my fingers are already, I don't want to move them over to my mouse, I could just do Command I, or in my case it's Control I, Control I. Come on. Control I. Choose getter and setter, and we can select all of those. You click generate, and it'll generate all the getters and setters for you. Again, this is what IDEs were made for. This makes your life easier. What we just did in designing this class too, that's a lot of what you're going to have to think about when you're building classes. What properties does it have? What do I want it to have? What do I want it to do? So properties are things, right? Usually nouns or states. If you want to think Boolean, true, false is a state. So nouns are states, and then methods are verbs. Things we want to do to this class. We want to get something, we want to set something, we want to calculate something. It always has a verb word in it because it describes what it's actually doing. Okay, so we added pizza. Great. Now, I'm going to suggest we do one more class. Because we got a pizza, and we got something that we're going to run to order pizzas. But I want to make an intermediary class. I want to make a pizza order class. Because how many pizzas do you want to buy? Well, the pizza class ain't going to tell us, because the pizza's one pizza. Right?
We can make a quality class.
Hmm?
A quantity class. A quantity, stuff like that.
Yeah, like an order class. Yeah, like an order class. So let's make an order class. And this order class will have, we're going to keep this a little simple. I'm not going to have like arrays of pizzas. I mean, I could. You could have an array of pizzas. But we're just going to have an integer class with number of pizzas. Now again, if we did an array of pizzas, because I can do that, okay, pizza is a class, I could say private pizza array. Okay, it's perfectly legal. We'll leave that. What the hell? I'll show you what we'll do with that in a minute. So anyway, so we have the pizzas. Now an order would have, what else might an order have? What else might be part of an order? We'll ignore the address or whatever.
Do you want it delivered or you come to the place?
That's awesome. So let's do, why don't we make that an is delivery? And that is, sorry, that's Boolean. We'll just assume if it's not if it's not delivery, that it's pickup. This is another naming convention, by the way, on Booleans. Booleans have usually an is or a has in front of the name, so it indicates it's an answer to a question. Is this delivery true or false? Has anchovies, true or false? Whatever the condition is. It's often, that's how you name a Boolean. Now, I'm not going to put a total on here. Why do you think? I'll calculate it here actually, but you're right. I want to calculate it. How many pieces do I have? Well, I don't know. The order doesn't know how many pieces it has, but the order can find out how many pieces it has, and it can add up all the costs and output a total. We'll see that in a moment. So the first thing we do, let's do getters and setters for these guys. So insert code, getters and setters. Go ahead, select them all, generate. Now we have getters and setters. Let's see. Let's see. Okay.
Can you scroll down a little bit more?
Sure.
So for my is delivery,
Mm-hmm.
it didn't do get is delivery, it just said is delivery.
Ooh.
Is that something on my settings that I need to change?
Did you do the lowercase boolean? That might be why. Lowercase boolean. That's okay. The lowercase boolean is that's okay. I did uppercase boolean. That's perfectly fine. The reason it named it differently is because it's trying to add that convention on there because it recognized it was a boolean.
Oh.
So if I renamed it, like here, if I do this, I realize what it's doing. I mean, in this instance, you'd want it to just be delivery if you're doing a Boolean, because it will, if we do if I'm not mistaken, it's gonna go ahead and, where did it do it? Yeah, see, it renamed it to is delivery.
Okay. Oh, okay. So it's just because of
So in this case, you wouldn't put the is in front of your Boolean, you just put whatever name it is, and then it will automatically, this is essentially the getter.
Okay.
It's gonna say is delivery. I will say one of the reasons we use conventions in Java is because other programs use other programs. We use other programs, and other programs could use ours. And the conventions make it easier for all these programs to interact. There's an expected behavior. So things like getter names and setter names, if you use these, it goes by the conventions, and what will end up happening is if you use this class in a larger piece of software or a framework, that framework will know how to use your class. It'll know how to set up an instance of the class, and it'll know how to populate it. And that's actually very important for a lot of software frameworks, especially when you get into the more complicated pieces of software. This is a piece of ordering, so it's not complicated. But at this point, we can come into our order pizzas and we can say, I want an order equals new order. And let's say, okay. So we're going to create a new order, call it order. We're going to create a new pizza called ZA1. And what were our methods on pizza again? Let's save this. Damn. Yeah, the size, cross toppings, and cost. What I'm going to do is I'm just going to do size. We're going to set the size equal to, I don't want that. We'll say 20 inches. if we set the crust equal to pretzel, and we can set the cost equal to what? $10? $10.25. So we create a new pizza, we instantiate a pizza. So this pizza is an instantiated pizza, it is its own thing. In this case, we have a default constructor, so we just do new pizza. And because of that, there are no default values for the size, for the crust, or for the cost, okay? To set a default value, by the way, when we go back to pizza, there's one of two ways to do it. We can do it in the setter, which is probably the best way of doing it. That way, or doing it in the constructor, I'm sorry. There's one way of doing it. We can do it in the constructor, or we could do it in the class itself. If we said, say, pizza size equals 18, then initially when we created it, it would be 18, and then we could change it. Remember, setters are mutators. We were changing things about that pizza. One more thing about the pizza. We're going to create we're going to do one thing in the pizza class that's different. So remember I had said that every object inherits, or every class inherits from object, right? Again, we'll get to what inheritance truly means, but that means we get some methods for free that we can use. One of those is called a toString method. On its own, every class you create, the toString method is garbage. Okay, it doesn't really return hardly anything or very much at all. And because of that, because we're using object's toString method, and object just says what's the random memory location of your object, we don't want to do that. What would we want to print out on the pizza? Like what toppings it has, right? Or what crust it has. Maybe the cost. Maybe we print that out. Well, to print that out, we could do something like this. We could say, over here, we could say, remember that S out? And S out, control space, and you get system out println. So system out println will print stuff to the console. All right? So let's say maybe pizza 1 crust is...
What was the shortcut you just said for that?
S out, S-O-U-T, and then control space. And it should give you system out print line, and the cursor should be in the position for you to start typing. Pizza 1 crust is, and we'll say za1 dot get crust. Now, a couple things about this line. Every string in Java that's between double quotations is immutable. That means it's a specific string in memory, and it will be reused. If you ever typed in pretzel again, it'll reuse the same one. It's in the same memory location, it knows where it is. Number 2, the plus symbol here is what we call overloaded. So you can add 2 integers, right? That's what the plus symbol does. The plus symbol also adds what?
String and an integer, just so it comes after the other, just printing out the message.
Right. In this instance, is concatenation, right? It's going to slam whatever the return value of get crust is, it's going to concatenate it onto this string. So it concatenates these two. We can also add 2 doubles together, but the adding of 2 doubles will be a double, a different number. The adding of 2 integers will be a different integer. If we added an integer here, it actually would return the string of this integer to add it, to concatenate it onto this string. Okay? So just to understand that the plus symbol itself is overloaded. It can do multiple things. In this instance, it is actually concatenating those two. At this point, we should save all of our files. So if any of your little files are bold up there, you want to save them. Okay. Now again, on the IDE, you've got a couple of symbols up here. Oop, where am I going? So there's this hammer, which is a build symbol, build project, which you can click on it, and it'll run through some stuff down here. Holy crap, that's big. Let me just want to see what the heck. Syntax, default character, comment, end of the year. Where is highlighting? Really? Market card says number operator. String. That's it. Okay. So where is editor? Sorry guys, I'm just. So console. Really? Wow. All right, we're just gonna have. It's just gonna be really, really large. Yeah, that's funny there. Why is it like, why is it so big? All right, I'll figure that out later. All right, so anyway, so we built it, okay, which is just fantastic and great and whoopity-doo. So that's the little hammer. The hammer with the sweeper brush on it is what's called a clean and build. So what a clean and build will do is it'll take your old project files that were built before, it'll dump those, it'll trash those, and it'll build brand new ones. Sometimes Java gets confused when you're typing along and you build and build and build and build. Sometimes it'll get confused and it'll start saying, oh, this class doesn't exist, and you're like, I just wrote that class. Sometimes in those instances, especially if you rename a lot of stuff, you want to do a clean and build, because what it'll do is it'll take all the crap that it's trying to refer to, it'll trash it all, and it'll rebuild the project from scratch. Meaning from.
If that's the case, what's the point of doing just a regular build?
It will build on the fly if you tell it to, but a regular build is just to build it. It will build it. Yes, can you clean and build it every time? Sure, but you don't necessarily need to, because what a build will do is it'll compare what has been changed since the last time and only build those files. The best one is this little run guy, this little run dialog, run project. So when we click run project, what it's going to do is it's going to look for a main method in our project, one main method. It's going to say, where's that main method? And it's going to start running from there. So when I click this, it's actually going to say, hey, pizza one crust is pretzel. Notice we said pretzel here, we do get crust here, we concatenate the two, and we output. Okay? And that's great. But what if we want to be a little more verbose about it? What if we want to say more about the pizza? Not that we really give a rip, but we could say a few things. So what we're going to do is we're going to do something a little different. I'm going to use that insert code, and we've already done constructor, and we've already done the getters and setters. But notice, if you go and you insert code, you got a couple other things here which are kind of interesting. The one we're going to do, we're not going to deal with the rest of them. The one we're going to do right now is the toString. For now, just let everything get generated. We're not going to worry about it just yet. For now, everything that's clicked, we'll just generate it. Okay.
Oh, that's so nice.
Now, a couple things about this. This ampersand, or not ampersand, I'm sorry, this @ symbol, @ override, That signals to Java that we're overriding a method that's in a class above us. And in this case, it's object, because that's all we inherited from. So we're overriding it. This is called an annotation. Java uses annotations pretty extensively nowadays to indicate things to the compiler. In this case, we're indicating that we're overriding a particular method. The toString method didn't just come from somewhere. Every class inherits from object. Object actually has a toString method on it that we can override. We'll get to why this mechanism works a little later in the class. Just for now, know that there is this mysterious toString method that is available to us, and we can choose to either write our own or use what is provided. It's automatic.
You asked me a little bit. What's it doing?
So, all right, so we'll back up for a moment. Remember I said every class inherits from object. Okay. Let me go back to... So object is the base class in Java, period. This is kind of like Eve, okay, if you're into that thing, sort of. This is the base class. This is it, okay? This is fundamentally the class all other classes inherit from and refer to. One of the things on object, because object has a few methods on it, one of the things that is on object is something called a toString method. This toString method returns a representation of the object. If you leave the toString method, if we call toString method, in fact, what I want to do, I'll show you. Don't copy this yet, because I'm gonna comment this out. Oh, here, I'll just go ahead and let's go ahead. What?
A comment down to on your toolbar on the top right. Those are the comment dots.
On the top. Whoa.
Right, yeah, just to the right of there. Just to the.
Oh, to the right.
All right.
Oh, okay.
Those are comment,
Yeah. Okay, that's fine. Okay, so let me do this. I'm going to show you if I do. One of the methods on ZA1 is toString, okay? This toString came from object, okay? If I do toString and run this again, okay, save and run it again. Great, it's a pizza at 7852E922. Pretzel crust, okay? This is a random memory location right here. That's all it is. So it's a representation of that object. Well, sure it is. It tells me what object it is by package and class name, and then it tells me the random memory location it's at. Although this is great, and if I were troubleshooting a Java JVM environment as to what was going wrong actually inside the running code, this would be awesome. But I don't give a rip about that, okay? Normally, no developer gives a rip about what memory location is at. What we do care about is an actual visual representation of it, a true visual representation of it. So to do that, we have to do what's called override the toString method. Well, now we just undo. Okay. So if we override the toString method, now we can actually put something useful in here. Now, mind you, this default really isn't that useful. It's okay. But it at least gives us something. And if I run this again, notice I changed it. Instead of using the old toString method, it uses the new one we just created. Okay. If you want to start where I'm at, I just uploaded the pizza project, what I have currently, to Blackboard.
Can you show how to zip? For some reason, mine when I export it doesn't.
Okay, so you choose the project, so the project's highlighted.
Oh, okay.
Then you do File, Export Project to Zip. Now here's where I messed up. This build zip is actually where the zip's going to be. So at this point, what you want to do is you want to browse
I'll browse that.
and like save it to your desktop. In this case, I'll just be saving it over what I already have. So if you're hopelessly lost or don't really care and don't want to code anything, just download it from the site and we'll pick up where we are. Download it, import it. So really when you have something you want to get a representation of, because you just want to print it out because you're interested to see what's happening with your objects, this is one way of doing it, okay? And you print out what's relevant to you. In this case, we don't have any toppings, so we could just, we could just remove those. So the toppings in this instance are going to always be null. We're not going to deal with toppings right now. They're just part of our model.
My output is still the same as it was before. We did the override.
And now if you save it and run it, it'll output that. Okay, so that's cool. So we're outputting a pizza. Awesome.
So when I'm exporting in the zip, I have to rename the actual file name? Does it just-
Well, you don't necessarily have to. I mean, if you know the path, you could just wipe out the path and do it. It says a .zip on there, but like this guy right here. I mean, if I said
But you have to keep order pizzas .zip in there.
yeah, you have to keep the .zip in there.
I got you.
It doesn't automatically do the zip thing. Yeah, the .zip isn't automatic. And if you click browse, then yes, you do have to retype the name in the save. It's not really useful that way. Okay. All right, so we have this pizza thing. Okay. So just like with ZA1, let's see how complicated. Should I make this more complicated or less complicated? We should just end it here. Let me see what else we could do. We could set the cost. Let's output.
Can we get, just for the assignment one, it looks like we're gonna need some user input.
Yeah, let's do some user input. Okay, so couple things about user input. What we're going to use is we're going to use the scanner to input from the console. Okay. The scanner is kind of a rudimentary input system. Whatever you input, it'll input. We're not going to talk about Right now, we're not going to talk about really validation yet, like data validation, but is one thing we're going to do later on. We're just going to go ahead and import data as much as we can from the user. So let's say, I just got to take a look at. Okay, so we're saying that this is, I'm saying in as an input. And this is the, okay, so this is the syntax on it, and I'll clean this up in a moment. So you want the word scanner, then whatever you want to name it. I'm just naming it in, you can name it whatever you want. New scanner, and system in is where the input's coming from. So it's coming from system in, which is going to come from the console, as we'll see in a moment. Now scanner is going to, you'll see these red lines. Again, if you do control, stupid fixed inputs, control command I.
What is this doing?
We'll get to what it's going to do. We're going to use it in a moment. But right now, what we're saying, again, we have to create objects, and then we can act upon the object or have the object act upon stuff, right? So we got to have an object to actually do something. So in this case, I'm just creating a new object. The new object is a scanner object, which will allow us to actually do user input into the program. So if I do, if I import, I'm going to import Java util scanner. Notice my imports changed. So I'm going to get Java util scanner in there.
How did you do the
Wait,
import?
I'm wondering if it is, I'm doing Shift Command I, but it might be Shift Control I for Windows users. You can also right click and you'll get the
I didn't
It's,
see it.
fix imports.
Oh, okay.
That's on mine. Obviously, you would have to right click and you'll see the
Yeah.
quick command for that.
Okay. So we just import that.
Mm-hmm. Okay. So if we're going to have the user input say something, the size of this pizza, right? What do we first need to communicate?
We have to ask them a question.
We have to ask them a question, right? I mean, we have to tell the user, hey, you need to give me the size of the input. If we do this scanner and we just say, hey, next input, the cursor's going to sit there. Your user's not going to know what in God's name is going on. So the first thing we really need to do, S out, and we need to say, man, I'm being too formal, I think. So what size pizza would you like to order? Okay. Okay. At this point, our size is an integer. So we're going to say, we're actually going to say int size equals in dot next int. Okay. By the way, each line is ending with a semicolon, just like in C# does that, right?
Mhm.
It's all ending with a semicolon. All right.
Now, when you put the int size, are you creating a variable right there?
Mhm.
So you're just using a public variable just to show.
Yeah, in this instance, because it's not a part of the Order Pizzas class, I don't need public-private protected because it's a part of this method, this main
essentially
method.
a read line is what you're.
Pardon me?
It's a read line. That's how.
Yeah. Well, this is a read line right here.
Right.
And it's
Yeah.
reading it into this variable.
Right.
Okay.
Yeah. Sorry,
Yeah.
two different languages are.
Precisely. That's essentially what this is that we're doing next int, which is going to read in. Read line is actually for strings. This one will pull the int
Right.
in.
Yeah, it's just a read, right.
And I think there is there's actually.
At least understand it too.
You do.
Okay.
I did this first until it clicked.
So we have the size at this point, and because we're not gonna really verify it. So and then what I want to do, I'm gonna move this pizza. Oh.
Can we just move the pizza up and then just use the set size?
I'm just gonna do this. Yes. Okay. Now I'm putting these in blocks so I can copy them and paste them so I don't have to keep doing this. So we want to ask them what kind of crust on that pizza. And then this one is, this one's actually, and crust, and we want in, and this is going to be, should be next line. Okay. And then crust is going to go here. At this point, we're just going to set the cost. It makes no sense to actually ask the user how much they want to pay, unless you're running the pizza Kickstarter. How much you want to pay for that pizza? Although I'm sure there's a store like that. I'm going to change pizza just slightly. Oh, actually, no. I'll leave that for a moment. All right, I'm going to save this. Okay. So when we run this now, okay, what size pizza would you like to order? Let's say I want 18-inch. I hit return. Oh, should be. That should not have done that. Which one? Next. There we go. Let's try that again. I might have had the wrong input. Yep. Okay, so what next line did is next line kind of grabbed, when I hit return, it kind of grabbed that return as an extra character, so it kind of assumed that crust was a return. So that's why it said, what kind of crust on that pizza, and then printed out the pizza. So I had to change it to next. Scanners are, there's a couple of methods on there that are not really interchangeable. So now I can say, you know, and notice here, my size is 18 and my crust is bagel. Okay. Now that we got this toString method, I can actually show a couple things too. So here, if I, So if I bring this toString method up here, okay, and you would say, well, what reason would you have of bringing a toString method up there? So remember I said there's two types of ways to do default values. So if we did size equals, 28 inches and crust equals doughy, and cost equals $100, because we're greedy. So if I enter those in here, when I create a new pizza, I'll show what that means in a moment. Okay, so when I create a new pizza here, we're going to see that that comes in with the default values that I set in the pizza class. Here we go. See, size 28, crust doughy, cost 100. Those are our default values. That's one way of doing defaults. The other way would be to put it in a constructor that you control. So now I want to order a 12-inch pizza, and I want the Swedish fish crust. Oh, it only took the Swedish. See, this is what I mean by you got to be careful with the scanner. The next only takes to the space. Notice my crust is not Swedish fish; it's only Swedish. So you have to be very kind of careful when you're using the different methods on the scanner. But here, notice again, we had defaults that were overwritten by what we did inside of this class. Okay. For all of your projects, I want you to have a main class, but I want that to be in a class that's the only thing it has is the main method. Doesn't have any properties, doesn't have any, you can use some, when we talk about constants, you can use some constants, but you really shouldn't have anything else inside of the class that's running the program except the main method. Everything else should be done outside in other classes, much like this. In other words, if I want to build a pizza order, I better have an order pizzas class, and I better have, I could put everything in the order pizzas class, right? I mean, I could have made it a list of pizzas and whatever. I could have made a method inside of the order pizzas class that said, generate order and ask the questions and scan the input and all that stuff. And I could have had, my order pizza class in here, and I could have said run that thing and output the cost. There's many ways to do that. But never should you be filling your main, where your main is, with a bunch of properties and a bunch of static methods, and you're running all this stuff from that same class. Build other classes to run from here, just like this. Because that's how it's done in the real world.
Shouldn't we probably have like a view class where we ask the questions and get that stuff too?
And a lot of the examples in the book are going to have a main method with a bunch of crap in it, and static this and static that. Okay? Granted, it's the book. And if you handed in something like that, I'm not going to dock you, at least initially, but we'll get to that point where I'll be like, I won't accept this anymore. Okay? But you could change it so that you had two classes, one of which had main, and the other just had the properties and methods that you want to call. Okay? Then you create a new one of those, you call those methods, and you're done. And copy, literally, you could copy and paste. It's not like I'm asking you to retype everything. Lord knows I don't want to type any more than absolutely necessary. Seriously. Copy and paste is your friend. That's why I show you the IDE, because let it do stuff for you. Let it build all those getters and setters. Don't type all that crap out. Leaves more time for thinking. So yes, this is how, and I'll upload this too, so you have an example of what the scanner is. Anything else that I can show you? We're not doing debugging yet. That's what this breakpoint is. That's what this is.
Is that the stop?
That's a stop point. Yeah, it's a break. It's called a breakpoint. And if you, so it's the difference between this little run icon and this guy. Okay. This other run icon will run until you get to the breakpoint. And look at what happened. It turned from red to green. And now I can take a look at what are all my little variables. Here's ZA1, here's order. The classes I made. If I twiddle, here's the size here. String doughy, double. And actually in here I can actually go and change. I can go and change values.
Is there like a step through as well?
Yeah. Notice up here, now that I'm at a breakpoint, notice what popped in here with these icons up at the top. So the run icon just continues to run it. Pause will pause it. Stop will finish the session and go out. The biggest ones to note are the step over and step into. Okay. System out print line is a static call to the system class. We get the output and we print a line. Okay. So this is a static and then a method on that static, a static method on that static that we can call. Okay. So this is available to us. It's a couple of classes and then a method on it. If we say step into, we're going to go into like the Java code and it's going to show us what is being called inside of each of those, which is not only horribly confusing, when you're talking about like the lower level language stuff is horrible. Stepping into your methods will be much easier because you wrote them. You'll know what that is. You can step into it and see what's happening, but don't step into it on this. I'll show you what happens. So if we step into this, this is the step into. If we step into this, oh, come on. Here, see, here's the print line method. Yay, like you understand any of this. Okay, like I understand any of this. Synchronize this, wait a minute, what is this? Oh, prints a string and then terminate the line. The method behaves as though it invokes code link print string again. All right. If you're really interested, go ahead, step into it. It's fine. Just know that I've been coding for 15 years. I don't do this because I don't really understand the guts of the language. I don't really need to for the work I do. Okay? But I know it's here. If I really needed to investigate what's happening at a lower level of the language, I have the ability to do that, but it's not really useful from our standpoint. To get out of it, you would actually do the step out, and it will come back to like the next line. Okay? Now, from this point, though, if we say, here we go, where's our step over? Here's our step over, step over, step over. Oh, we gotta, I'm sorry. We gotta say 30 inches. Now at this point we get set size. Now if we want to go into it, notice what happens. We get into our class and here's our set size method. So again, step into will step into the method at the very first line of the method. For your classes, that's a good thing because then you can see what's going on inside your methods. But for Java classes, things like printline, or if you use the scanner classes, don't step into those guys because it's a rat hole of I don't understand. And you don't need to at this point.
So would that be the original code that people would write?
That's the language code. That code's probably 10 years old, maybe more. That's like the original programmers writing it with really, really primitive stuff in there, simply because that's what all that has. You can go into and source code's available, freely available online. You can go in there and take a look at what they did, and everything's documented very well. I don't understand the documentation half the time, so I'm not expecting you to. And if you do, quite honestly, come up and teach me something because it's not easy to understand, okay? Because it's low-level language stuff. It's really taking care of some basic housekeeping, and it's not for the faint of heart. Not saying that you will never get to that point, because you can if you really are interested, but it's better for your stuff at this point. And then we can just step out and we can just run it to the end. Okay. So that's inputs, outputs. To set the breakpoint, what I did is you come over to this number line over here and you click on the line, you right click on the line you want, and you have a breakpoint menu. In this case, I can disable this breakpoint, or I can toggle the breakpoint, which turns it off. Disabling it will just not stop it, but the breakpoint will still be there if you want to enable it later. It's up to you. But that's all a breakpoint is. Now, if you do a breakpoint and you hit the green arrow, it just totally ignores it. It just blows through. So I just want to be impertinent at this point. It's getting late. So it blows right through it. It blows right past your breakpoints. All right. Okay. We got about 10 minutes left. Is there anything else anybody would like to see?
We just run through the assignment just to make sure that we
Sure. Absolutely. And I would recommend, by the way, getting the textbook. And if you don't, I would recommend getting the textbook. At least look at it. If you're not going to get it, the problem is there's going to be a lot in the textbook that I may or may not cover. Okay, I can't get to everything that's in there. We loosely covered chapters 1 and 2 today, and probably a little bit of chapter 3. So, and I touched on some points that are in much later chapters, and we'll come back to those.
It's available now.
Should be. Yeah, it was available. It was available.
This week it wasn't there. It wasn't available.
It's available online. That much I know. As far as a hard copy, that I couldn't tell you.
Yeah, is it free online or is it cost?
No, it's all that. It's all that paid crap. Paywall. Set up the Java environment. We actually went through and did. And using NetBeans. So name the class with main, create another class named tip that will allow user to enter the name of the restaurant, cost of the meal, and percentage to be tipped. So there are 3 properties right there, right? Name of the restaurant, cost of the meal, tip percentage. The tip class will calculate the tip amount and display with the name of the restaurant. Okay. Go away. So anyway, so this is the thing. Your tip class is going to have getters and setters, and then we'll have an additional method that will calculate the tip and display the name of the restaurant, calculate tip amount, and the cost of the meal with the tip. So you're going to have something. You're going to have something like, if we had a tip class, you're going to have something that's going to be like, you have something like that, okay? And this will, you know, in here you might have I'm going to use primitives for this.
Pretty much this, we're just gonna need 2 classes and we'll ask for the input in main.
Yep. You're going to ask for the input of like the cost, the restaurant.
Yeah, the restaurant name, the cost, tip amount, and just return it.
Mm-hmm. See, and in this instance too, it's up to you as to whether you want an actual tip. I can't spell. Save my damn life. Okay. So it's up to you at this point whether you actually want tip, but this is not going to be something you'd actually input. You wouldn't even have a setter for it. You might have a getter for it, but you wouldn't have a setter for it because, or tip percentage. I'm sorry, tip percentage. Sorry, you're going to have it do this. Sorry, you have tip percentage, and then you might have. I'm sorry, you might have an actual PRIVATE. God. Then you might have an actual tip amount if you wanted something separate. Like if you wanted tip percentage to be one thing that they enter and then the actual tip to be an actual value, you could do that. But what I wouldn't do is I wouldn't have this one have a setter. Maybe a getter, because this tip is based off of the cost and the tip percentage. So it's a calculated value. You're never going to actually set this from outside this class. If you're going to set this, you're going to set this from within this method.
Wouldn't we want that method to be an int that we just return the, we're going to return all the values in that one.
Yeah, you're going to return this. This is going to be void because you're going to print out a bunch of stuff. There's going to be a lot of sys out. Your cost is this. You are rich because you paid this. And where do you work? You give good tips and that sort of thing. I mean, go nuts, whatever you like. But this is the sort of thing, this is like the tip class, and then you need a main class to actually call this tip class and do like the scanner in should probably be in that to set the values in the main class. You do the scanner in, set the values on your tip, okay? What is the name of your restaurant? Tip.set restaurant name or whatever. So, but that's how you would handle it. So the main class is going to instantiate one of these. You're going to have scanners bringing in the input, setting those values, and then you just call calculate. And calculate should do everything else. It should calculate all these. It should calculate this value, use the tip percentage with the cost, restaurant, and then display everything. So this method does it all.
So you're saying we can do some of the scanner input in the main method?
I would say you'd have to do all of it in the main method.
Really?
I wouldn't do any of it in this.
What if we create another class that's just user input, output,
Sure.
and then?
I'm
just
open to that.
Okay.
If you want to section that off. One thing I would guard against is the whole, I have so many classes, I basically have one main class and then I call my other class .run and it does all of it, right? If run is pretty well designed, then I'm okay with it, but I've seen those types of classes that just don't really function that well or don't really look that well because they can't see what's going on. Because all of a sudden you're calling other classes and calling all these different methods from all these other classes, and it's like, well, what are you really doing? At some level, you have to have a little bit of procedure to figure out where things are lining up. I'm not against it, but if you want to put everything that would be input into that main and load it into a tip class in a separate class and just call get my tip and from the main class, yeah, okay, I'm good with that. As long as you, again, show that work in that other class. But then, you know, at this level, it's like, how much of an abstraction do you really need? You know, you just want to question, if you start creating classes just for very specific things, then you want to back up and say, well, why am I doing that? Okay? Sometimes, and I'll try my best to give feedback to show you guys when stuff is happening. If there's anybody around who's actually had my class, that's one thing I do is actually give feedback on the crap you hand in. Oh, I'm sorry, on the beautiful work you guys all hand in. The wonderful programs that I will see from you. I leave comments on them, okay? And if it's okay, if it's doing okay, I might leave a short comment. But if I can see some improvement, I'm going to tell you where I'm, you know, hey, you got full points for this, but you really want to watch out for X, Y, and Z, okay? I'm not going to write War and Peace, but usually I'm a good paragraph.
How much are you concerned about commenting for us in our code?
For this first thing, because I haven't mentioned it that much, I'm not going to worry about it. We'll talk commenting more next week, especially after I see what you hand in, because we will talk commenting. I would say I am of the mind that if it's not self-explanatory, right, then you should comment it. So a generic getter or a generic setter that takes in a value and sets it directly to that value. If you said after entering tip percentage, your set tip percentage took the cost and actually calculated the tip at that point, I'd want to comment on that as to why you chose that over a different method. Okay? So if you're doing something, you know, unusual with a class, something like calculate and display tips should probably have a little comment on it. One thing about comments, for if you want to comment, right, on calculate and display oh, come on, there's no comment in here. Well, you just have to do it the old school way. So for something like this calculate, where you're doing a lot of things, I would actually just put in a quick, it doesn't have to be a lot, okay? It doesn't have to be like a paragraph and a half. You can put a couple lines. Hey, this will calculate the tip and output all the relevant data. It's really simple. One thing I will say, and here, I'm going to take this break. Okay, so one of the things I just want to inform you of, if for some reason you want a tab character or a new line character, right? Let's say I want to make it a couple lines down or whatever. A new line character inside of a quote will be a backward slash n, okay? That'll be a new line, and it looks like it'll when you save this and print it, it'll look like this. All of a sudden you'll come down here and see now my entry is on 2 lines down, okay? This is more important on output. A tab character is a /t like this, but usually kind of goes like if I would want it in the middle of something, okay? So here, notice I'm going to delete all the spaces between pizza and wood. If I run this, sorry, gotta save it. It says pizza, would you like? Oop. Come here, you. Tab. This should save. There we go. notice the tab character comes out. Okay. So if you're trying to line stuff up, those two will help you in your output if you do those within quotes. The slash is an escape character. There are actually other codes you can use with it. These are the two most prevalent, is tab and new line. So if you wanted to line up specifically like you do restaurant name, tab, that, cost of meal, tab, and then you'll get things to line up if you want, or if you're OCD about that sort of thing. I don't know.
And then for, because next week's obviously online.
Mm-hmm.
How's the format for that going to go?
I really haven't worked that out. As I said, I'll be here next week for, what I might do is I might give I'm trying to think if I'm going to do like a little video just on the main points for the assignment, or to go over the assignment. I hate typing, so video would be much better. I might also have a couple of files out there for you guys to try stuff with, or if I come up with something as a skeleton like I did here with the tip, I'll put those online for you guys. But it's up to you. If you email me, if you need to see something or if you're confused about anything, please send me email. Okay? I'm online most of the time. Weekends I'm going to try to get it as much as I can, but definitely weekdays I am online all day. So I will get your email. I will respond as soon as I possibly can. And if you guys are not feeling it, if you're like, hey, really isn't working, can we do something different? Let me know. Okay? I want this to be, needs to be more of a collaborative deal, because I need you guys to succeed, which means I need to help you as much as I can. But in turn, I don't really kind of know what you need. So you need to let me know, and then I can help. I can intercede. And I promise you, anything I record or whatever, I'll put online for everybody. Everybody will get it in Blackboard.
You recording today?
Hopefully, everything recorded today.